Let's continue with this digital interflow, just the basics, right? You have maybe heard about coding, right? You know channel coding and source coding, and then now there's network coding. How does that fit together? So if you look at source coding, the only thing that source coding wants to do is it removes redundancy for efficiency. Channel coding introduces redundancy for reliability. As I said this morning in Communication Network 1, of course you don't remove one redundancy and add it here later on. There are different types of redundancy. This is, so to speak, the stupid redundancy. This is the intelligent redundancy, right? And what is network coding doing then? Where's the difference? So these two are only operating point to point, where the network code works in a distributed way. So whatever you do on one end has an impact on the others. But here, this is only encode, decode. And we do something, if you understand what the butterfly is doing, we will introduce the concept of a recoder, which means we could encode at one point, we can decode at the destination, but in between, we could recode. That is a new concept. We will introduce also this to you. So here's an example, right? If you have a given network with all the nodes down here, you have, these are the lower layers, the gray one, like physical layers, right? And then on layer 5, 6, 7, you have some source coding, end to end. And here is source coding between D and C, end to end. And then you have channel coding, hop by hop. Every channel that you see hop by hop has its own channel coding. So this could be channel coding A, channel coding B, and so on. But if you will have network coding, there could be encoding in between the network, which is not known by the endpoints. Suddenly in the network, like in the butterfly, the coding did not start at the source. It happened where it was needed. And this is quite interesting, and this is we have to find out what kind of topologies can we do. Can we do only the butterfly, or are there different architectures? And we go through some wireless network examples, right? And most of them are based on the feature of a wireless channel, which is broadcast. So I'm sending one packet, but everybody can overhear the packet, okay? So this is what we do, and therefore we call it, it's not about butterflies. If you see here the gray notes, this is only a paper, a journal that we have written, in this case together with our co-workers Meda, Montpetit and Rosenberg, where we said there are some myth busting. Because when network coding came up, a lot of people did not really understand how is this possible. I think with the butterfly, the example is quite easy, but some people, for example, said, okay, it only works with 2 packets, because they understood the XOR in the butterfly. Others, there were EU projects getting millions, and you know what they did? They did not think about network coding, they just looked, where is the butterfly in the topology of my network? And whenever they find the butterfly, they applied the XOR. So it's also not good, right? So we have to understand really the basics of that. And if you see here a mesh network, there are a lot of nodes and they're somehow connected. And then you could find a very good overlay code and understanding the whole topology and make the right decision. But from the engineering point of view, this is not what we want. We would like to break down this bigger graph into smaller graphs, right? For example, if you look at this, there is a two-way relay, Alice and Bob. I hope everybody of you have heard about two-way relay. There's a chain, which Alice and Bob are 3 nodes, right, in a chain, but there could be even a longer chain. There is an X topology and a cross with overhearing. This is more one family down here. The colors correspond to the architecture that you find here. For example, the chain is here the purple-blue, right, what you can see here. And the cross you can see here, and this is the cross with overhearing. You don't see the difference in this example, but you will see it later on.